Hello everyone, welcome back to EWorks. In this tutorial, I'm going to show you the overview of all standard mates in SolidWorks assemblies with clear and simple examples. Mates in SolidWorks define how parts fit and move in an assembly. Think of them as invisible constraints that align, fix, or guide parts relative to each other, just like hinges, sliders, or glued faces in real life. I'm going to show you the details of each mate by building two simple parts in SolidWorks. The first one is the pyramid with the hole and the second one is the pin. The parts are quite simple. It's a rectangle with 50mm side each, extruded to 50mm with a draft of 20 degrees. And then there are two holes with a diameter of 10mm and a depth of 10mm. Finally, another part is created, which is a pin with diameter 10mm and extrude size of 20mm. Let's move to SolidWorks assemblies to see the details. This is the SolidWorks assemblies window, and we can start by importing the first part. I'll go to browse and import the pyramid which we have created. After this, you can click anywhere in the windows and the part will be imported in the assembly window. I will start with creating a copy of the pyramid simply by clicking on the already imported part and then holding the control button and then dragging the mouse outside so that a copy will be created. We will start with exploring the coincident mate. It is one of the most important and essential mates in SolidWorks. It simply brings two faces, edges, or points together so they lie on the same infinite plane. Think of it like placing a book on a flat plate. The surfaces are touching and aligned. Let's start by mating the two base faces of pyramids together. You can simply click on this mate button and then you will see that a table will appear on the left side with several standard mates in SolidWorks. These are coincident, parallel, perpendicular, tangent, concentric, log, distance, and angular mate. You will see that by default there is no mate selected and SolidWorks actually automatically detects the required mate, which can be changed as well. So I will simply select the face of the one pyramid and the base face of the second pyramid, and you will see that the coincident mate appears. I'm going to flip the direction of the mate because I want two pyramids to be opposite to each other, and I will click OK. You can see that I can move this pyramid, but this mate actually restricts the motion of the pyramid along the plane of the base. I can also rotate this only in that direction. However, it cannot be rotated in vertical direction, otherwise the planes will not be coincident with each other. Coincident mate can be added between two planes, between two points, between two lines, line and a point, line and face as well, and other combinations that you can make. So I will show you another combination which is the coincident made between the vertex of the one pyramid with the other. And when I press OK, and now if I try to move the part, you can see that we can only rotate the part along the vertex which are coincident. Let's add another mate and join these two lines. So we can add multiple mates on a single part. So you see that now I can only flip this pyramid in one direction, which is the angle around the x-axis. So you can explore other combinations with line and surfaces, with points and lines, etc. Next up is a parallel mate. This mate keeps two faces or edges running in the same direction, always equidistant, no matter how far apart they are. It's like making sure two walls in a room stay perfectly aligned without ever meeting. In this example, I'm going to make the slanted face of one pyramid parallel to the other pyramid. So I'm going to select the face and let's select this one. And instead of coincident mate, I'm going to select the parallel mate here. And when they are parallel, I will go to the 2D view, and if I try to move these two pyramids, you can see that the faces that are connected through this parallel mate remains parallel even if I move the pyramid anywhere. Let's see if I can rotate this. So yes, I can also rotate the pyramid along some random direction. However, you can see that the faces are always parallel that we selected. Similarly, we can assign this parallel mate between two lines as well. Now let's look at the perpendicular mate. As the name suggests, this mate forces two faces or edges to stay 90-degree angle to each other. Here I'll make the side face of this pyramid to be perpendicular to the base face. So let's select these. And now if I try to move the pyramid, you can see that the selected faces, they are always perpendicular to each other. Similarly, we can make the two sides perpendicular to each other. Simply by selecting the edges or sides, we can make them perpendicular to each other, like this. And if I try to move this, the selected sides will stay perpendicular to each other. I'll shift to this view so that we can clearly view the sides that we have selected. So here we have these sides. So this angle between these two sides, it's 90 degrees. I will remove this mate as well. The next in line is the tangent mate, and for that I will import the pin that we have created. This mate is used when you want a curved surface to just touch a flat or another curved surface, like a wheel resting on the ground. In this example, I'll make this cylindrical face of the pin to the flat face of the pyramid. Once I apply the tangent mate, SolidWorks keeps the two faces touching smoothly, no overlap, no gap. This mate is super useful for rollers, cam, or anything that needs to be moved while staying in contact with another part. So I'll show if I try to move this circle now. You can see that in the 2D view, you can see that the circle, it's always tangent to the base plane of the pyramid that we have. We can move it outside, but it still stays the same. Now let's look at the concentric mate, one of the most important mates for round parts. It aligns two cylindrical, conical, or spherical faces so they share the same center axis. Think of inserting the pin into the hole. They rotate freely, but they stay perfectly aligned. Here I will align this cylindrical pin with the hole in the pyramid. So I will create a copy of this pin and then I'll go to the mate, and after going to mate, I will select the cylindrical face that I want to be concentric with the cylindrical face of the hole. So here you see that the SolidWorks automatically detected this mate, and the hole and the cylindrical face, they are completely aligned. So when I press OK and I try to move this pin, you can see that it is free to move in the direction of the hole. Next in the list is this distance mate. So it is similar to the coincident mate. However, if we want to specify an offset between two surfaces, this can be used. For example, I want this face of the pen to be connected to this particular face with a distance of, let's say, 10 millimeter. You will see that there is this offset of 10 millimeter, or I can specify this to be 5 millimeters. So this way the pin will be restricted to the hole with this offset of 5 millimeter. And finally we have this angular mate. So what I'm going to do is I will align these two lines using the coincident mate. Let's see. So we have this coincident mate so that these two pyramids are connected to each other. If I want the faces to be oriented at some angle, or the edges to be oriented at some angle, instead of 90 degrees, I can use this mate, which is the angle mate, and I can select the faces and specify the angle. So you see, when I change the angle, let's say it's 120 degrees, the face will be aligned at 120 degrees from the base. So this can be used to specify the angles. And when I press OK, you see that this is aligned at 120 degrees and the lines are coincident. In the end, we have one remaining mate under standard mates, which is this lock. This can be used to lock the position of two different assemblies in SolidWorks. So if I select the pen and the face, I can select this lock mate. When I press OK, you will see that we are not able to move the location of the pen using the move or rotate button. So this is all about the standard mates in assemblies. Thank you for your time, and we will be back with the new tutorial soon.